From the accompanying table, find A, f of g of 1. Our first step will be to evaluate g of 1. We'll locate an x value of 1 and then determine the corresponding function value. When x is equal to 1, we see that the corresponding function value for g is 0. So we're going to put 0 in place of g of 1. Now we need to evaluate f of 0. 0 was an output for g, but now it becomes an input for f. So we locate 0 in the x column and then determine the corresponding value for f. When x is 0, we see that the corresponding value for f is 2. So f of g of 1 is equal to the number 2. For b, we're asked to find g of f of 1. So first of all, we locate 1 for x and evaluate f of 1. From the table, we see that f of 1 is equal to 1, so we substitute 1 for f of 1. Next, we evaluate g of 1. The output of 1 now becomes an input, and the corresponding output is 0. So g of f of 1 is equal to 0. Notice that function composition is not commutative. In other words, when we switch the order of f and g, we can end up with different results. For c, we're asked to find f of g of 0. So first of all, we locate 0 for x and then evaluate g of 0. We see that g of 0 is equal to 1, so next we need to evaluate f of 1. f of 1 is equal to 1, so we conclude that f of g of 0 is equal to 1. For part D, we're asked to find g of f of 0. So first of all, we locate f of 0, and then we substitute its value into g. From the first row, we see that f of 0 is equal to 2. And then from the third row, we see that g of 2 is equal to 3. So g of f of 0 is equal to 3. Finally, for part E, we're asked to find f of 2. So first of all, let's evaluate f of 2. The result is 3, so next we need to evaluate f of 3. f of 3 is equal to 0, so f of 2 is equal to 0.